Hey guys, I'm here to help you out with the notes for section 6.1, just on circles, basic terms, arcs, angles. These first couple terms up top, mostly review. For circumference, I'm just talking about the distance, essentially the perimeter of the circle, the distance around my circle, what I'm highlighting right here. As far as radius goes, it's just that segment that goes from the center of my circle to any point on my circle. So it could be this segment, it could be this segment right here. And as you guys know, if I double the radius, what I'm going to get is the diameter. All right, so the diameter passes through the center, all right, essentially two radii back to back. Its endpoints are on the circle. All right, the next term is probably new to you guys. All right, for a secant, biggest thing is it has to be a line. All right, and the other thing is it cuts through my circle at two separate points, here and here. Okay, so it has to be a line, so I should have arrowheads on either end, and it's going to go through my circle at two separate points. So that's a secant. This right here, this could be a secant cutting through my circle at 2 points. Next two terms are both probably going to be new to you guys. The first one, chord. All right, in this case, it has to be a segment, and its endpoints are going to be on the circle. All right, so as you see, it says touches the circumference at 2 points. So these are the 2 points. All right, doesn't extend outside the circle, it's a segment. So that could be a chord, and if I have an endpoint here, this right here in green could be considered a chord. Technically, the diameter is a chord. It's just a special type of chord in which it goes through the center of my circle. Last one, tangent. All right, in this case, it states that it is a line. Technically, it could only be a segment, could be a ray. All right, but the important thing about a tangent is it touches my circle at only one point, one specific point. All right, so that's where it touches my circle, and here's my tangent line. This next section just kind of reviews the vocabulary for different parts of a circle, but this first question, the set of all points in a plane that are equidistant from a given point, called the center. This is essentially my definition of a circle. Apologize for my bad handwriting. Second one, they're talking about a segment whose endpoints are on the circle. So if we look at our picture on the right, this segment right here has endpoints on the circle, points T and U. All right, so in that case, what I'm referring to is a chord. Now, it could also be referring to V and R because they're endpoints of this segment that goes through my circle. All right, but in that case, what they're referring to is the next question down here. All right, which is my diameter. This next one's referring to a segments whose endpoints are the center and any point on the circle. So I know it's coming from the center and then connects to any point on my circle. So what they're referring to here is the radius. All right, so the radius goes from the center to any point on the circle. Next one has to be a line, all right, in a plane of a circle that intersects the circle at exactly 1 point. All right, as we said earlier, it's going to touch the circle at 1 point. What I'm referring to is a tangent. Tangent touches the circle at 1 point. And the last one, I mean, by process of elimination, you might guess what it is. Once again, it's a line, and it intersects my circle at 2 points. All right, so a tangent is 1 point, and a secant is 2 points. The next part of this section talks about a specific part of circles, arcs. All right, what exactly an arc is, it's a part of a circle with endpoints on the circle. So they kind of highlighted here, showing arc AB. All right, and notice the way it's written over here. So it's not like segment AB with a straight line across. It's an arc, so it has that little curve that goes on top of AB. All right, to show that this is the part of the circle that I'm referring to. Now, what goes along with that? All right, an angle whose vertex is the center of the circle, all right, is a central angle. All right, you can see it highlighted right here. So this would be my central angle right here, angle ACB. All right. Next term, they're referring to an arc that measures less than 180. What we're going to call that is a minor arc. Okay, and you can see the minor arc over here on the right highlighted in red. All right, it's less than halfway around my circle. All right, it's a smaller piece of my circle, as opposed to more than 180 degrees, which would be a major arc. Okay, in this case, the major arc would be this huge blue section. All right, which is definitely more than 180 degrees, definitely more than halfway around my circle. And then for the last one, if it's exactly 180 degrees, what we call that is a semicircle. All right, so a semicircle in this case would be like arc ADE. All right, what I've highlighted here in red, it would go halfway around my circle. All right, notice that a semicircle, the endpoints are always going to be the diameter, AE, right here. So halfway around would be 180, and obviously I know that all the way around would be 360 for a full circle. I am going to give you guys a couple examples for this next U try, all right, but I want you to come up with your own as well. So for the first one, a minor arc. First thing I know, minor arc, as I stated up above, less than 180. So I'm looking for any piece of the circle that's less than halfway around. So what I could say right here is this little piece. All right, so what I'm going to call that is DF by the two endpoints, and then make sure you have that curve up above to show that it's an arc. Hopefully yours is written a little bit neater than mine. Next one, major arc. As we said, a major arc is more than halfway. All right, so we could start at F where we left off last time, and I just want to make sure I go more than halfway around. All right, so in this case, my endpoints are F and C, but I want to use 3 letters to name it. So you could either put G in between those two or H. Doesn't really matter. All right, so we'll call it FHC, and I'll use my arc symbol for up above. Next one I'm talking about is a semicircle. As I said, a semicircle is exactly halfway around. All right, to make sure that I go halfway around, though, I want to look for the diameter of my circle. So my diameter, it looks like, is going to be H2F. All right, so I could either use this section down below or the piece up above. All right, so if I'm using this one down below, it would be HGF. All right, and then make sure you use that curve up above to show that it is an arc. All right, as I said, I want you guys to come up with your own answers for this U try section. For this next example, what they're looking for is specific arc measures and actually an angle measure as well for B. First thing I would do for problems like this is just focus on the circle that they give you. Try to fill in everything else that you can. All right, first thing I notice is the arc measure they give me here is 70 degrees. What that means is that this central angle here is going to be 70 degrees. As you can see right below that, we have 80 degrees. What that tells me is that this arc, BC, is going to be 80 degrees. Down here, this arc is 80, so therefore I know this piece is 80. Now, as I stated earlier, I know that the entire circle is 360 degrees. Well, the arcs that I do have are 80, 80, and 70. So I know all three of those together are going to add up to 230. So what I'm going to do next is I'm going to subtract those two, which leaves me with 130. So I know that this final arc from D to A measures 130 degrees, which means that angle 2 is 130 degrees. Once I have all that filled in, it'll make it a lot easier for me to go back and answer my questions. First arc they're looking for, BC. I think I already marked that in my picture right over here, B to C. It's the same as that central angle, so I know it's going to be 80 degrees. Next one, measure of angle 1. We found that early on. It's the same as the arc measure. The arc is 70, which means angle 1 is 70. Next one I'm looking for is arc of AC. So this one's a little bit longer. So we're going from A through B to C. Well, I know this one up here is 70. This one down here is 80. So it looks like together they're going to be 150. Last one, ADB. I know right away this is going to be a major arc. Now, in this case, what direction do you go? You're going from A to D first. All right, well, you're never going to go all the way around the circle and overlap. So if I tried going this direction first, A to D, and had to go to B, what's going to happen is I'm going to go all the way around my circle. That's not going to be the case. So now I'm going to go back and I'm going to go the other direction. So I'm going from A to D, this direction, and then up to B. So I've almost gone all the way around my circle. So I've included the 130, I've included the 80, and I've included the 80. So I have two options. I can add up those three pieces, 130, 80, 80, or what I can do, I know all the way around is 360. The only piece I didn't include in this arc is this right here. That's 70. So what I could do is just take away that, which is going to leave me with 290. Now, before we get to this next example, what it's referring to is length. So this is a little different than what we did in the last example with measure. So when I'm talking about length, I'm talking about the distance between those 2 points. So if I wanted the length of this arc, AB, I want to know how far is it? How many inches, how many centimeters, how many feet? All right, as opposed to the measure, what I was looking for before, all right, like an angle measure. Now, to figure out this arc length, what I need to know, obviously, is the circumference. I want to know how far around the entire circle is it. And then what I want to know after that is how much of the circle am I looking for? All right, do I only care about half of it? Do I only care about a quarter of it? What's going to tell me that is the central angle. So let's see if we can try this out in the next example. So for this problem, what I'm looking for is the length of BG. So arc BG, how far is it from point B to point G? Obviously, this 40 degrees is going to be important. The other thing I'm going to need to know is the circumference. So let's worry about getting that first. All right, first I need a formula for circumference. Circumference is 2 pi r. All right, r being the radius. Okay, so it looks like I have the radius down here is 6. Okay, so for my equation here, I'm going to do 2 times pi times 6. Now, we can clean that up a little bit. I'm going to keep it in terms of pi, but I can multiply the 2 and the 6, which is going to give me 12 pi. Okay, so I have the circumference down, 12 pi. The next thing I have to do for this is use the central angle. Okay, so the central angle I pointed out earlier is 40 degrees. So for my equation to find the length, it's going to be 40 degrees, the central angle, all right, over 360. All right, what this is telling me is what part of the circle I want. I don't want the whole thing. I don't want all 360. All right, I want 40 degrees out of 360. 40 degrees out of the whole thing. And what I'm going to do with that is I'm going to multiply it by the circumference. All right, well, we found the circumference earlier. It's right up here, 12 times pi. Now, to multiply this, if you don't remember, all right, don't worry about the pi right now. We're going to keep the pi at the end because I'm going to keep it in terms of pi as it states up here. Okay, I'm going to multiply it by 12, which is really 12 over 1. You're going to multiply straight across. All right, 12 times 40, 360 times 1, which is going to give me 480 over 360 pi. All right, last thing I want to try to do, if I can, is reduce that. Okay, cleaned up my workspace a little bit. All right, hopefully you had a little bit more space in your box. You were writing a little bit smaller and neater. But now I just need to reduce this. So obviously I can get rid of the zeros, so immediately I'm down to 48 over 36. Greatest common factor between those two is going to be 12. So now when I reduce it by 12, we're going to end up with 4 over 3, and don't forget pi. All right, so that's my final answer.